Again, good afternoon. Great pleasure to be with you, yesterday, today, and over these days. And what I wanted to do is, take around 45 minutes to share with you some of the work we are doing on cities, on how our IoT is changing cities, and then having more a conversation. We had like 15, 20 minutes for Q&A and discussion together. But first of all, why are we passionate about cities? 4 numbers, just, about cities: 250, 75, and 80. Cities are only 2% of the surface of the planet, but they're 50%, actually a little bit over 50% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a little bit more sustainable, they can be a big deal globally. And, well, what can we do? Technology can actually suggest some interesting things we can do today. Now, if you think about technology and digital technologies, once upon a time, people thought that they would have made our lives more and more virtual. That's a picture from the 1990s. At the time, people thought the internet connectivity, would basically destroy cities. That's a quote from the time is Gilder 1995, the same year when Nicolas Negroponte wrote a book called Being Digital. And Gilder said, we're headed for the death of cities. Cities are leftover baggage from the industrial era. Well, what does this tell you? The first thing it tells you is never make predictions about the future, because no prediction could have been more wrong than this one. We know that over the past few years and decades, cities have been thriving. It's a picture from China. China this century might actually build more urban fabric than all of humanity ever built. We know, as we were saying, that since 2008, half of the world's population lives in cities, but this number could swell to 5 billion by 2030. So what has happened really is that networks and connectivity and so on hasn't killed our need to come together in physical space. The need to have cities. And I think what we are seeing here in Cape Town is just one example of that. We want to be together, to exchange ideas, to fulfill the basic function of a city, which is human interaction. So that hasn't changed. At the same time, what is changing is the convergence of digital and physical. It's the convergence, if you want, of the world of bits and atoms coming together with us in the middle. And that's what we're passionate about, and that's what we are looking at both with our lab at MIT, mostly on the campus, the main campus in Cambridge, also with a small lab in Singapore, also with our design office in New York, Italy, and London, and with some of the startups that are coming out of both, have been coming out of both over the past few years. So I want to share some of this work with you. I mix it. There's some academic work, some research work, some design work, from the office. So I mix all of this, but starting from some key questions. And those are the questions I've been hearing over the past few years from mayors all over the world. The first question is, what about mobility? How is mobility going to change in cities? We all know about how technology might revolutionize the way we actually move in cities, and mobility is such an important component of how you design and make a city. And the second thing is what about office space? We all know there's a big change going on in the way we live and work. Because of connectivity everywhere, we can work in a much more flexible way than just a few years ago. And so the question is, how is office space going to change? And the third point, I tried to touch about retail. We also know that it's something that's changing very fast because of e-commerce. I was with the mayor of Paris some weeks ago, and one of the things that was discussed was, well, think about the richness that you got in the streets of Paris today. What if that were to disappear because of online commerce? How different the city would be, and what can we do as designers in order to avoid that? And finally, how all of this can actually create new urban experiences. So again, I want to share with you a few of the things we're doing in this space, for instance, about mobility. Today, we can look at a city like this, like we couldn't just a few years ago. There's actually a city of Lisbon, and it's mapped using billions and billions of data points collected from the taxi network in Lisbon. This visualization was actually at MoMA, the Museum of Modern Art in New York. It was done by Pedro Cruz from our lab at MIT. But again, it shows you a way we can capture and describe the city today, thanks to digital data that didn't exist just a few years ago. And if you take the same data and analyze it, you can find interesting things. That's exactly the same data in New York. So taxi data, you see every dot is a pickup or a drop-off. A yellow dot is a pickup. By the way, which place is this in New York? Yes, JFK Airport, very quick. And if you land at JFK, you were there. If you zoom out, you see all of Manhattan. By the way, if you look at this map carefully, there's no roads on the map. But actually, all the roads just come up because of all the dots. The dots are so dense that all the road network is covered. And you see JFK was over here, and you see Manhattan and all of the boroughs. I'll tell you also a little story about how we got hold of the data. The data was made accessible by Mike Bloomberg when he was mayor of New York. And as you all know, Mike Bloomberg, as an entrepreneur, he developed a very successful company, Bloomberg, that has data at its core. So I remember in his office in New York, he had a little sign that went, in God we trust, everybody else bring data. And so what he did as mayor was actually make accessible a lot of data to people, to citizens and to everybody, to researchers, in order to describe the city. So that was part of his open data initiative, sharing all the data here from the Taxi and Limousine Commission. So what we started doing at the beginning was asking ourselves the following question. If you look at those 2 points in Manhattan, you got hundreds of thousands of trips connecting them in the course of the year. And so how many trips could be shared without creating much delay for people? And the interesting thing is that that question, that seems quite simple, cannot be solved with traditional mathematics. In the world of big data, sometimes you need kind of big math or new math in order to solve it. So what we did, we developed a new method called Shareability Networks. Here is the paper. If anybody's interested in mathematics, you can find everything on our website, but that's the paper we published. And so we analyzed the shareability networks that you see here, all this kind of, that tells you how many trips could be shared. To the left and to the right, you see those two graphs. One is more dense to the right, and that's because if you tolerate a slightly longer delay in your arrival time, you can share more trips. So mathematically, you could say, imagine you want to take everybody to destination when they need to be there, give or take a small delta, a small delay, 1, 2, or 3 minutes, you decide, can be variable, and then what is the minimum number of cars you need to do that? Now, you run this, you then solve the problem with big data, and what you find is quite interesting, that in Manhattan, you could take everybody to destination when they need to be there, but with 40% less vehicles than what we have today. Now, 2 interesting things. The first one is that when we did this, Uber had not launched Uber Pool yet, and they saw the results, they reached out, and then we started a large collaboration between MIT and Uber, and as you know, Uber Pool does exactly that. Allows 2 people going more or less in the same direction to share a ride. The other thing is when the paper was published, the New York Times did a review of the paper. And the journalist in the New York Times said, well, this is interesting mathematics, this is interesting research, but New Yorkers really don't want to share anything. Which is not the case, actually, because now that we have a lot of data from Uber, and we've been analyzing it, it turns out that Uber Pool has been a big success, that in San Francisco, over 50% of all trips every day happen by Uber Pool, which means 2 people going more or less in the same direction, sharing a ride, which is 1 less car on the road, which means less congestion, less energy consumption, and less pollution in our cities. So it was a simple example of how we can start from the city, get data that we didn't have some years ago, analyze the data, and use the data in order to think about new services we can develop in the city. Okay. There's a more recent piece of research we've been doing on similar data. It was published just a few months ago in Nature. And what we did here was actually look not at how many trips could be shared, but what would be the minimum fleet you need in New York, especially if you think about tomorrow condition when we'll have a lot of autonomy, a lot of autonomous cars. So this is real data initially. Again, here you see real data of mobility in the city. For instance, here are the taxis. And then we try to mathematically find what is the minimum fleet we need in a city in order to keep it on the move. So what you see to the left and to the right is actually a situation is this today and how it could be tomorrow, with again 60% of today's vehicles still satisfying all the mobility of the city. Again, just by changing the intelligence of the system. And incidentally, also this is something that now is being spun off by MIT with a company we created to do this that will be more and more important as we move to a world of self-driving cars. And again, we like to share all the data with people and with citizens. So if you go on our website that you see here, you can play with the data yourself and see what the consequence of new algorithms could be on running the city, on mobility in Manhattan. Now, so this was about the intelligence in the IoT, Internet of Things, at the scale of the city. But IoT is also changing the vehicle itself. What you see here is actually a vehicle. The vehicle is like an average car that you can buy today, that today has many thousands of signals, measuring everything about it. Every kind of thing that happens in the vehicle, from how you turn the steering wheel, how you open a window, how you press on the pedal on the brake, and so on. All of that is recorded, and that's information that the car is collecting. You could say that the car is like a computer with a lot of sensors just on wheels. And so we started looking at this, how this can tell us interesting things about the city. So how the car could become like an ambient sensing platform. And in particular, also how it can help us to understand the infrastructure that you have in a country. If you think about the United States, for instance, there's a deficit in infrastructure that's estimated at over $1 trillion. And so how can we scan that infrastructure and better understand where we might need to invest and improve it? This is particularly important because you might have seen images of this that happened in Europe kind of less than a year ago, but also quite a few bridges that have collapsed in Europe, in the United States. This was a famous collapse several years ago, many years ago. It was called the Tacoma Bridge, which started resonating and then, collapsed. And so the way you monitor a bridge today actually is by, first of all, looking at what type of bridge you have, and then trying to install sensors of them, fixed sensors. For instance, this is the Longfellow Bridge next to in Boston, next to MIT. To the left is MIT campus, to the right is downtown Boston. A Longfellow Bridge was actually monitored a few years ago, and then at that point they discovered it was in very bad structural shape, so they closed it from one day to the next. It had to be almost rebuilt at a cost of several $100 million. So, that was kind of a lack of constant monitoring. They created like a big issue in terms of investment and also in separating two sides of the city for several years while this was under reconstruction, and actually just opened a few months ago. So as I was saying, the way you monitor a bridge today is by using fixed sensors like the one you see there to the left on the Golden Gate Bridge, or also to send people who will do inspections on the bridge. Now, both of them are very expensive. If you put sensors like you see to the left, they may cost you anything between $50,000 to $500,000 per year. And then if you send people as well, that's a huge cost in order to monitor, in a country, tens of thousands or hundreds of thousands of bridges and pieces of infrastructure. So what we started thinking was, well, what you get from sensors, which is curves with the frequencies of vibration of the bridge, could we get that in a different way? The interesting thing is that today, most of the phones we have in our pockets, like the three you see there, have accelerometers. Also, the car has an accelerometer. So we equip the car with those three phones, and also we put the little yellow box that's a professional accelerometer. And inside the car, you got the accelerometers that the companies, the car manufacturing companies, have installed on the car. So we say, can we actually use this information in order to better understand how the infrastructure performs and do a quick scan at the level of a country? We decided to start with the Golden Gate because we know everything about the Golden Gate. It has been studied from a structural point of view very, very well. So the question is, can we actually get the same information that has been collected with those sensors you saw before that are fixed on the bridge? Now, so we started going back and forth across the Golden Gate, collecting all this data, around 100 times. That's why you want to have graduate students helping with the research. After the 100th time, they were stopped by the police. We got a bit concerned about, what was going on. But we had to explain, and we're just collecting this data from the accelerometers. And it turns out that, then you see all the vibration. What you collect in the car is the sum of the vibration of the bridge, plus the vibrations of the car. You combine all of that. But it turns out that when you analyze it, then you're able to get back from this picture, which is all the accelerometer data, to get back the main frequencies of the bridge. So the key thing we're doing now is try to scale up, again, with data from Uber, and say, from Uber in the United States and Allianz, the insurance company in Europe, and say, can we actually use all this data and just very quickly do a scan of the infrastructure of an entire country? Now, this doesn't mean we know everything about the bridge just by collecting this data. It's almost like when you go to hospital, and the first thing they do, is measure your temperature and your blood pressure. And then if there's an issue, you can do additional testing, an MRI, an X-ray. So here again, it becomes a very simple way at the level of an entire country to collect data, first type of data about the structural health of the infrastructure, and then decide where to go and do additional tests and research. So that is about really the fact that the car itself becomes more and more intelligent. And we saw before the thousands of sensors we have today in a car. But if you have those two little sensors at the top, like two little ears, those are called LiDAR. What the LiDAR does is a three-dimensional scan of the city. Then you feed all of this into an artificial intelligence system, and the car drives itself. And as you all know, this is not the future or the distant future. It's really the present. As we speak, there's thousands of cars, self-driving cars being tested all over the world. Self-driving has different levels. The full level is autonomy level 5. So we're not there yet in all conditions, but all the research and the technology is progressing very fast. You might have read that Google started just a few months ago to have robotaxi offer services to people, commercial services in the city of Phoenix. Now, when this happens, again, everything changes. And everything changes because in the 20th century, the car was one of the most inefficient pieces of infrastructure. Today, still, a car is used on average 5% of the time, and is parked 95% of the time, which means that not only it's not used, but actually it uses valuable real estate in our cities. Now, if you go to self-driving system, however, things change, because you can use the car, and then somebody can give you a lift when you go to your office, and then can give a lift to somebody else in your family or to anybody else in the city. So we create a new system in between public and private transportation. And so they can have a big effect on the city. Now, as I said, this is happening now. When everything will be self-driving, other things might change, such as this. You're all familiar with this. It's a well-known traffic light. And traffic lights, arrive on our roads when cars arrive on our road. But if you got an intelligent system where every car knows where it is and where all the other cars are, you don't need to stop anymore. You can keep on going, just avoiding collisions, like this. Don't try it yet. I showed this at a presentation in Naples, and they told me, so what is new here? Now, I'm Italian, so I'm allowed to make such politically incorrect jokes, but I need to tell you I got corroborating evidence from a former Italian minister who publicly said that in Milan, traffic lights are instructions, in Rome, they're suggestions, in Naples, they are Christmas decorations. So again, it's an interesting mathematical thing to solve, to study such type of intersections. So what you see here is some papers we've been doing, looking at queuing theory and trying to extend queuing theory to model an intersection. And for instance, what you see here is it's a real intersection in Singapore. To the left and to the right, it's the same frequency of arrival, so the same number of vehicles and frequencies arriving to the intersection, to the left and to the right. But actually, to the left, managing the intersection using the most sophisticated traffic light system we have today, and to the right, using a slot-based system, like what you have in airports. And look at the difference in terms of number of cars waiting or delay per car to the left and to the right. So again, the idea that the intelligence of the city can help us to run better many processes. In this case, same number of cars, you just change the way you manage the intersection. They can change a lot in terms of throughput, queues, and so on. Also in terms of pollution, because normally the intersection generates a lot of pollution because a lot of cars need to stop and then start again, so consumption increases and pollution increases. So this is some of the work we're doing at MIT so far, mostly the research side, and some of the work we're also using then at MIT to spin off into different startup companies in the Boston ecosystem. But I want to share with you a couple of examples of how this can impact also architecture. And I want to share with you two projects we are doing with our design office. The first one is this one. It's one of the tallest buildings in Singapore. I will not tell you too much about the design itself. We're quite passionate about it. We'll see at the middle is like a tropical forest overlooking the city of Singapore. So there's a public space in between. What you got at the top is a lot of offices. In the lower part is serviced apartment. And that place in the middle becomes, we call it the Green Spring. Like a plaza, a tropical plaza overlooking Singapore where you can spend time, meet other people, work with others, like a communal space for the whole tower. It also has some other advantages in terms of the height of the building increases and you get this kind of green space in the middle that ties in the two communities at the top and then and the bottom. But beyond that, I will not tell you too much about it. Is that at the beginning we had to plan for auto parking for this building. But at the same time, we've been working with the government of Singapore and advising for all of their self-driving deployment. And if you think about self-driving, one of the consequences of what I was saying before, the fact that cars can keep on being on the move, is that we might need much less parking. Now, there's still discussions about do we need like maybe 20% of today or 50% of today, but certainly, everybody predicts a reduction in the number of parking spaces. And so the question was, initially the city wanted to put parking underground, and the question was, well, why would you want to do it? It's going to be very expensive. You build a large piece of urban infrastructure, and maybe in 5 or 10 years, that's going to be useless. And so what we did, we said, why don't we keep it above the ground? So it's going to be, first of all, cheaper to build, but at the same time, we do the distance between floor and ceiling, so the floor to ceiling height a bit higher. We move the ramps outside. We make the structure inside more flexible, so that the same garage space tomorrow can become something else. It can become a place for working, can become have different activities. And I think that's one of the key challenges we have today. When we build a city, when we make buildings, they will last for 50, 100, 200 years. But actually, the usage might change in 5, 10, or 20. Think about mobility in the city and self-driving. And so I think the important thing is to future-proof, to see actually how we can make sure that what we build today will be compatible with different future scenarios. Now, the future is not something we can predict. It will depend on many things, many decisions you will make in your companies, mayors will make all over the world. So the future is not set yet, but at least if we are compatible with different futures, we can make sure that infrastructure we build today at great expense will be useful in a shorter time frame, while usage might change substantially. And then the second thing I want to share with you is some work we've been doing with Google in Toronto. As you might know, Google's sister company, Sidewalk Lab. Sidewalk Lab is part of Alphabet, and they've been engaged in urban development. The first big project is in Toronto, and here, again, the input by Alphabet was to think about a city that is all based on self-driving mobility. And why self-driving mobility? Also because, as you know, Waymo, another sister company, is one of the most advanced in developing that technology, has been developed with Fiat Chrysler. A lot of these are the Pacifica, autonomous Pacifica. I told you before, are already robot taxis in Phoenix and in other parts of the world. And so in this case, it was about, well, when you got that, then it's interesting because the car knows exactly, in a digital way, knows exactly what is allowed, what is not allowed. So you don't need to have a fixed urban infrastructure. You can think about a flexible urban infrastructure. So think about the road that is like this in the morning, when you got a lot of cars, but then the same road could be like this in the middle of, after rush hour, when few people use it. Or it can become like a place for a block party in the evening, like this. So the idea to use then the programming of the physical infrastructure to respond to this new condition in mobility. And again, what we've been doing is think about this kind of little Roomba robot that goes around and reconfigures the road. And if you go to Toronto in the Sidewalk Lab place, you'll find a prototype of this, where people can actually play with it. You go to different lights, you can reconfigure it, and it becomes like a first prototype of what the city could become later. I want to finish with a final thing about mobility, which is this picture. And I'm sure you've all seen pictures such as this one, with the idea that drones, will change urban mobility in the future. Well, I don't think that's going to be the case in cities. And the reason I don't think it's going to be the case in cities is that technology can change many things, but technology cannot change physics. And physics means that if you take a weight, the weight of our body, or a few people, or a big parcel, and you want just to keep it in midair, even without moving it, you need a lot of energy just to keep it there. And that energy generates a lot of noise, a lot of wind, and a lot of disturbance. If you are familiar with some of the helipads in some of the main cities around the world, think about Manhattan. In other those helipads, you got tens of flights every hour, and everybody complains. But if you wanted to have an impact on mobility in Manhattan, you don't need tens of flights an hour. You need tens of thousands or hundreds of thousands. So that, I believe, will never be possible in very dense cities. Drones will be very useful, in the countryside. There's very interesting projects in Africa where there's less infrastructure here in this continent, in some parts in the center, and so then drones are being used in order to basically create a much more flexible way to connect 2 points. So I think we'll see many applications, but not really the old dream of the Jetsons. So drones being used in cities to shuttle us around all the time. Also, drones could be interesting with small, in small scale. Been working on different type of application. This is something we've been working quite a lot in the past couple of years, using drones for doing collaborative graffiti, smaller scale drones that can help create art in cities. And I'll show you another example that we've been doing at MIT to try to address a very important problem we have at MIT. The problem is that the MIT campus was built by engineers. Some of you might have been there, and it's very confusing to navigate. For instance, every building has a number. I'm in building 9 to 50. Sometimes I send people to building 36, 134, and they get lost on the way. So we developed this system with drones in order to help them, and in particular to help a special category of Harvard students who tend to be lost all the time. Here is the video. Just for a team in the back, maybe we can increase a bit the volume.
Welcome to MIT. Where would you like to go? Follow me, please. The Computer Science and Artificial Intelligence Lab is the largest research lab at MIT and one of
To
the
your
world's
right,
most important
the Media
centers of
Lab.
information technology
To your left,
research.
the Status Center.
Follow me, please. Approaching your destination.
You have arrived. Welcome to Senseable City Lab.
Goodbye.
Actually, I need to tell you that the student who were playing the kind of dumb Harvard student was from Yale, so he was very happy about that. You know the rivalry between the two universities. So anyway, moving on to the other points, mobility is changing very rapidly, but also office space is changing a lot. Let's say an article I did in the Harvard Business Review just a couple of years ago, where they gave this title. I mean, the article argued that we still need to go to physical places in office, but what we do there is different. And it is different, and this really relates to the very structure of our cities. In the past, that's Le Corbusier, one of the key architects of the 20th century. The idea was to separate everything in a city. To do a city like you see to the left, where work, sleep, and leisure are totally different parts of the city. But if you do that, it's not a very efficient way to create a vibrant community. Good places that are empty during the night or during the day. So since the 1960s, 50s, and 60s, many people all around the world, including Jane Jacobs in the United States, argue for mixed-use developments. But we think that today things are changing again because of digital. Something that's really changing the transition between public and private space and the very structure of the buildings we inhabit. In order to look at that, I want to take you on a quick tour of the MIT campus. So what you see here is the campus by the way, in the middle, you see that is Longfellow Bridge we saw before, the one that was rebuilt. You see Boston downtown. Here you see Harvard, don't bother, up there. And MIT was one of the first universities to be totally covered by Wi-Fi in the early 2000s. And so we started seeing a big change in the way people live and work. Before, people used to work, students used to work, as you see to the left, and now, a lot of working areas are more similar to what you see to the right. Now, I need to tell you, this picture is a bit extreme. To the left, you got the most depressing computer room I could find, no daylight and so on. And to the right is a beautiful sunny day. I need to tell you, when I left the other day, it was raining and snowing, it was not the same. But I think, that's part of a bigger change that we're seeing all over the world. We used to work like this, even if this is Jacques Tati making fun of cubicles in the movie Playtime. But still, these were working places that we've seen all over the world. We still see today, but today we see more and more something like this. And the change between the two is that today we have more freedom. Technology has liberated us. A few years ago, we were chained to a desk, to a desktop computer, and to a desk that was connected with an internet cable. So we couldn't move. We are there, and we had to execute things. Today, most of the tasks about execution, maybe we don't need to do anymore. AI can do them, or they're being outsourced somewhere else. And the important thing in the office becomes, how we come together. exactly the same reason why you're all here today, how together we can actually bump into each other, exchange new ideas, find serendipitous new connections that may actually change what we're going to do in the company or in the place we work. So our point at the beginning was if all of this is produced by technology, what about analyzing technology and networks to quantify and better understand what is going on? So we took the MIT campus and started monitoring all the data on the network of the MIT campus. And you see here, for instance, you can look at people where they are in the course of the day. Every bubble tells you how many people you have and how they move over the campus. If you look at the overall campus activities like this, so you see, for instance, let's say Monday morning, people get to MIT, around 9 o'clock. A few people leave at 5, not that many. Those are 9 to 5 people. Most people keep on working till late at night. Even in the middle of the night, there's a lot of activity. And the same thing happens on Monday or Tuesday and Wednesday, on Thursday. Not on Friday, where like all over the world activity slips away quickly in the afternoon. And then actually Saturday and Sunday, it's interesting. It's like, 2 normal days. You just remove 9 to 5 people with something quite fun. Every Sunday night, you got the little dent that you see there is between 9 and 10 p.m. And that's when people say, oh my God, tomorrow is Monday again. And you remember all the things you haven't finished before the beginning of the new week. So if this is kind of, you can call it the heartbeat of MIT aggregated, you can do the same thing for every room, and which is what you see here, the signature of every room. But tomorrow we'll be able to do this for every square foot or every square meter. And it becomes very, very interesting because it tells you how well space is used and also how you can combine different functions on the same space. Now, again, you analyze all of this data. I'll show you some of the first results. You look at, this is some initial analysis we did with frequencies, Fourier transform, with K-mean clustering. But what you find is really what I was telling you. A few years ago, this map of the MIT campus might have been a few functions very, very separated. And today you see this kind of overlapping of different functions on the same square meter. This is what we know, that the cafe is also the place where we work, and maybe we have a meeting. So this different way of using space, which we can monitor and also help optimizing. If your building has enough flexibility built inside it, you can keep on getting this data and really use the data in order to constantly reconfigure the building in a way that will better allow us to do the work we need to do. It goes back to the conversation, what we were saying before about flexibility and how technology might keep on changing fast, and so we need to build an infrastructure that is compatible with different way of working in this case. Now, I will add something on what we are doing right now that's still in progress, but so here I don't have the final results, but think about what is a great organization. Think about all the great companies you're coming from, or think about a university. Well, it's nothing else than a number of people connecting in physical space, connecting in digital space, and together trying to achieve something, to do something together so that the sum of the individual part is more than each of them individually. The total is more than the sum of the individual parts. Now, today, for the first time, we can actually measure all of that. And think about a future where, again, you're not going to rent an office space anymore. You're not going to do like today that you're renting maybe, in the past, you would rent X number of square meters. Today, you might go to a co-working place and say, I want to rent, 100 places for people to workstation and places for people to work. But think about the future where actually you're renting more like an infrastructure to increase productivity. You're renting real estate, which is not by the square foot or by the activities that you perform, but it's about how you are helping, enabling people to do what they need to do in that company. So what we did at MIT started looking at what is the productivity for most of us is papers and patents. So what we produce, we can measure that. And you see how that changes in all the buildings on the MIT campus. And we also looked at the diversity of the community coming together. When you got more diverse community, it turns out people tend to be more creative and produce more papers and patents. You see it here. And also looking at digital connectivity. So we believe that more and more we'll be able to measure the digital connections, the physical connections, what we do together. And that can really change a lot the way we design space and provide space as more like a platform to allow people to do what they need to achieve. Now, I want to share with you how we're using this for doing some, again, this is research we're doing at MIT, but we're using this in our design office to design different office spaces all over the world. We're working now in India and Europe a lot on co-working spaces. That's one of the largest one in Milan that opened kind of last year. This is another one in America. But I want to share with you also one that we opened a year and a half ago, which is the Agnelli Foundation building. And what we did there in this co-working place, We also try to do a building that knows in real time, as I was telling you before, exactly what happens inside the building. And the building then responds to it in different ways. Heating, lighting, and cooling, create your own climate based on your own preferences. So that becomes a way to give you, to focus on wellness of the people there, but also save a lot of energy. Because if the building is not used, you can actually save a lot because it's like your computer goes on standby. So I'll share with you some of the process for doing it. I like this kind of the way they interpreted on the Wall Street Journal was, the thermostat wars are finally finished. And actually, Koen, who's here in the room, did a very interesting building in Amsterdam called The Edge. That's also based on a very similar approach. The two buildings were featured together in the same article. So I want to tell you a bit more about the design process here. So this was a building that has very high symbolic value in Italy because it's the building where a startup in the early 20th century was started, and it was Fiat. It became Fiat Chrysler today, and one of the biggest conglomerates in the 20th century in Italy. And today, the Agnelli family is still the controlling shareholding family between Fiat Chrysler, Ferrari, Juventus, The Economist, and many other companies. So this was the house where everything started, and this house was built over 100 years ago, but then it was expanded in the 1950s. In the 1950s, when it became the foundation, the family foundation, then a number of architects were sent to the United States to all over the world in order to look at state-of-the-art offices of the time. And so they came back and designed state-of-the-art offices of the time. That's the part you see there to the left. And the state-of-the-art offices look pretty much like this inside, because that's how we used to work. We had cells, and we were there executing tasks. But as we were saying today, the reason we might go to an office space is very different. It's really human interaction. So what we tried to do with the design was really to break down a lot of the walls that were inside the building. The building is listed on both sides, so we couldn't change it that much, but we could open it up towards the city with this communal restaurant and public space. We could open it up inside to make connections between the different floors. It's a staircase that becomes almost like a theater where people can connect different communities. The same thing, creating like a porous structure inside the building, inside the new part you see here, and also connecting with nature. Nature, as humans, we've been living with nature for thousands of years. And only a few past 100 years, we actually alienate ourselves, close ourselves into buildings that look like fish tank in many cases. And so how can we actually bring nature much closer to us again? So that's what we've been trying to do. You see here the gardens. This is an orchard. There's no furniture yet in this picture, but where you can go and keep on working under an apricot or cherry tree. You see how the inside and the outside of the building, you see the offices inside to the left, but also the outside becomes a place where you can go and keep on working or meeting with other people, have a meeting, almost like an outdoor meeting room. So the combination of the two. This is how the system I mentioned before, where the building knows where everybody is and responds dynamically. We actually developed this, pioneered this with Siemens, the technology with them. You can see here some of the places before they were occupied inside. And also, the kind of the porous structure in the middle in order to create connections between different floors, in order, in this case, just to allow sound connection and visual connection becomes important so that the different communities are not separated by one floor and the other one. And the same principles apply also to the old part, to the historic part, where again the offices try to promote more connection between people. The stairs actually was closed in the 1950s. It was opened up. And I'll tell you a bit about that art piece that was done with Olafur Eliasson. Some of you might know Olafur, who did a beautiful sun installation in Tate Modern Turbine Hall a few years ago in London. And in that case, we were trying to do something to connect two sides of the building. Connection is the key word, really, connecting also, again, allowing more interaction between people, human friction. At the same time, here we had a privacy issue because on this side, to the left, you got some offices that need to have more privacy. So, but we still wanted to create a visual connection, and we did it with this art piece by Olafur that tries to create like kaleidoscopic wall. So you see nature, sun, and movement on the other side, but again, you don't have direct lines of view between one side and the other. And art, again, is very important in the office today. It's, again, something that helps us start a conversation, fulfill really that vital function we're talking about before, of the office as a place where we can, create new serendipitous encounters between people and where new ideas then are generated. Now, moving to starting to wrap up, I want to tell you also something about retail that's also changing very much. Think about the question I mentioned before that was mentioned by the mayor of Paris a few weeks ago. And, and you have all seen statistics such as this one. That's one of the many reports. Up to 25% of US shopping malls may close in the next 5 years. That's a huge amount of real estate. And all of that is because of e-commerce. Also, e-commerce becoming coupled with physical commerce. You all know that since a couple of years, Amazon bought Whole Foods. And if you'd asked me a few years ago, will I always go to Whole Foods in the US, I would have said yes. It's still an amazing experience to go to a market and so on. But now, I end up using Instacart probably 8 times out of 10. So if somebody is shopping for you, will text you. If they don't find something, we replace the product and take it to your home with no extra cost. So again, things are changing very, very fast. And so I want to share with you some of the work we've been doing here to see, what is then the value still of physical space. And for a few things, physical space is still stronger than the digital experience you can create. And so the first project we did was something for the World Expo in Milan in 2015, now 4 years ago. The theme of the World Expo was feeding the planet. And so it was about producing food and distributing, cooking food, but also selling food. So we were asked to do a pavilion called the Pavilion of the Future, where the brief we were given was about a future supermarket. Now, the pavilion is what you see there to the left. I'm not responsible for the design of that shoebox that was given to us, but we could do anything we wanted inside. And we knew what we did not want to do. We didn't want to do this. It's a beautiful picture by Andreas Gursky, but it's an alienating picture of the supermarket of the 20th century. Our idea was, to start from this quote by Italo Calvino, an Italian writer, was a character who one day goes to a fromagerie, a cheese shop in Paris. And this guy called Mr. Palomar starts looking at all the pieces of cheese and thinking about the stories behind them. And little by little, the cheese shop becomes like the Louvre. Mr. Palomar, visiting it, feels as he does in the Louvre. Behind every displayed object, the presence of the civilization that's given it form and takes form from it. So the idea that basically the interesting thing we can do in physical space is tell more stories about a product. And that's not a new thing. Many people try to do it in shops and supermarkets. This, for instance, was an experiment by Tesco, a big supermarket chain. This was in Seoul. It's in the subway. You see there's a train and people boarding. And the idea was you take your phone, you scan a product, you learn about it, and then you can order it. But again, if you look at this, it's alienating. It's yourself with a screen in front of you and another screen behind. Why would you want to do that? So our idea was, can we use technology to create something that resembles a bit more this? It's a beautiful 20th century painting by Guttuso of a traditional market. And look at the richness of interaction between people and products, or people and people through products. So the way we try to do it is by putting everything on tables. The table is a beautiful interface. As humans, we've been using tables for thousands of years to eat together, to share things, to sell things. And then, on the table you got the products, and as you touch the project, just seamlessly information appears about them. The initial sketch was this: you take an apple, if you want, you can buy, like today, in 3 seconds. But if you go 6 seconds, you may see a little bit about that apple. And if you got 15 seconds, you can actually get more information, like the video of the orchard from when the apple is coming from. The more you interact with it, the more you learn about it. And so we wanted also to create an experience a bit like a theater, so you would arrive from the top and see all of the product. These are, with the different layers of the physical layer, we see the product, but also the digital one that augments it above. And at the top, you got all the clicks, the aggregated data. It's almost taking the click measurement that you got online and bringing it into physical space. So this was a built pavilion. It got a lot of prizes, and also was among the top visited pavilions at the expo. Also, it was both a pavilion and a real supermarket, so you could go there, experience this, but also buy things. What you see here is different layers of information. Also at the end, this kind of big belly of the supermarket that brings products and from all over the world. People playing with it. A lot of kids loved it. Love to have this accordion of data open up in front of you as you move from one product to the next one. And again, when you start, just basic information, carbon footprint or nutritional values, but the more you play with it, the more you learn about them. Here's a little video. Here's a little video. again, the idea that in physical space, what might remain tomorrow is really the experience, new experience that we cannot do digitally. And it's the same experience in the office. It's about human interaction, or here interaction with products in a different way. So I think that's really, I believe, what is going to win in the long term in physical space, that every digital platform will, at least for a foreseeable future, not be able to undermine. And that's why I want to finish with a bit with urban experience a bit in a more general sense. By the way, this project was done at the Expo in Milan. The project I'll show now in a moment was done at the Expo in Zaragoza. We're now working quite a lot on Expo Dubai. That's coming up in 2020. We actually, it hasn't been announced yet, but we just won one of the main pavilions there. There will be a pavilion made of 3 boats coming to the site, and then like the old Mediterranean people being turned upside down and become the roof of the pavilion, become what then is the pavilion, what will continue sailing after the Expo. But in this case, I want to go back to something we did at the Expo at the World's Fair before 2015 in Milan, and that was in the city of Zaragoza, Spain. And in Zaragoza, the theme of the Expo was water, and so the mayor came to us and said, "Is there anything we can do by using water in a different way, using digital technologies and IoT?" And the idea we developed was, imagine you got a pipe, and on that pipe you got many tabs, opening and closing, controlled by a computer. Then you can create like a living water wall, where you can show images, text, or patterns. It opens up when you approach it. So the mayor liked the idea, and we got the commission to design the building at the entrance of the Expo, or the World's Fair. So you see the building, it was called Digital Water Pavilion. All the walls are made of water. You can show text or images or patterns. No doors or windows, but when you approach it, it opens up to let you in. And when you are inside, all the walls expand, and all the spaces expand and shrink based on how many people you have. The roof is also covered with a thin layer of water. So you will enter the Expo from here. That's a bridge by Zaha Hadid to go to the other side of the site. And then if you had too much wind, you could lower the roof to minimize splashing. Or at the end of the day, you can actually close the building and the whole architecture disappears. Hopefully without anybody underneath. We got sensors for that as well. Now, we had a lot of fun in designing the pavilion, but we didn't really think they would build it. And then what happened is, like 9 months before the opening of the World's Fair, the Time magazine put it in the list of the best projects of the year. So then they felt, forced, to do it by the Expo. So it was a rush in order to make it on time. This was before the opening. I like this picture because you see the guy with a trolley was going to the station that's quite close to the Expo site. I think the guy missed the train because stopped there and couldn't figure out what the hell was happening. So stayed there to try to see what was going on. This was still during the testing at the beginning. This was digital pixels on the top of physical pixels combined on the top of each other, so playing with light and water together. This was myself trying not to get wet. And the building has all the sensors around that detect you when you approach it, and when you approach it opens up to let you in. But I need to tell you what happened one night when all of the sensors stopped working. And that night we were terrified, because that night the building would keep on doing its own crazy things, like cats and holes and images and so on, but without responding to people anymore. But that night was one of the most fun nights ever. That night, thousands of kids from all over the city went to the building, to the pavilion, to play a new game. Not anymore a pavilion that opens up when you approach it, but a pavilion that you need to engage like this. And for us it was an important lesson, because as architects, as engineers, as planners, as developers, and we all think that we know how people will use the stuff we design. But then reality, especially reality in a new world made of Internet of Things, where buildings respond to us with intelligence, with artificial intelligence, almost like living things. And the reality, especially when it engages this type of buildings and the human interaction, then is always a surprise. In this case, it was a good surprise. Thank you. And as I said, I kept it a bit shorter so that we can have a bit of conversation. So if there's any ideas or comments or questions, we have a few minutes. So just raise your hands. I don't know exactly. They told me it was organized. Yes. Maybe I repeat the questions if you don't hear it in the back. Yeah. Actually, there's also mics here in front, but if not, if you speak loud, I will then repeat it for the others.
your concept in regards to putting parking up higher so you can transform later. I assume you're looking at how to transform those already billions of parking spots underground, bringing natural light in through fiber optics and things like this. Can you talk a little bit to that?
Sure. Yeah. You can. I mean, I think that there's two questions here. No? One question is what do we do today when designing a new building, and that's where I think the very important thing we were saying is how you can design it today in a way that's compatible with different future conditions. So future-proof it. Then you design it today. You change the floor-to-ceiling height and so on. With the existing infrastructure, it really depends a lot. You don't have a general solution because it depends if the ramps are, for instance, some of the most difficult pieces of urban infrastructure, either underground or above ground, is if you got parking spaces where you got sloping floors. There's not much you can do in that. Also, it depends on floor-to-ceiling height. Sometimes it's really too low, even in terms of regulation for doing other things. And sometimes you might end up with a condition where you need to demolish it and redo it. It's cheaper than if you had to really go inside and trying to adapt it. So I don't think there's a general solution, but yes, you're right. We can also look at fiber optics to bring light down. And in some cases, we are able to, it is possible to reuse that infrastructure. But I think most important is about how do we design for tomorrow in a way that we put together and reconcile these kind of two different curves, the long-term curve of the physical infrastructure and the rapidly changing curve of digital life. Yeah.
Hi.
That's it? Yes.
Yeah. I was wondering, what is China doing in this space?
It's a big question. What you mean in general in the space of all of this? You could call it in the space of smart cities.
Smart cities, technology, design. What are they doing differently, or whatever?
Yeah. Well, I'll tell you one thing that is happening in China, and a lot of things are shared. Think about self-driving. There's a lot of developments happening in the U.S., in China, in other parts of the world. A bit less on self-driving in Europe. Just at least deployments in cities, there's a bit less happening there. But I'll tell you something that's very particular to China that's happening now really almost on every new office building, which is using facial recognition to really know exactly who is in the building and where they are. Now, that is not happening in Europe and the United States. As you can imagine, it has also a lot of implications in terms of privacy, and there's a lot of discussion about this in different countries, but China is applying it. Now, without commenting too much on the other impacts of it, I think from a building point of view, you get a building that somehow knows exactly what goes inside and can respond to it in a way that would not be possible with any other type of sensor. So I think that really is probably going to produce a lot of data and a lot of understanding of human activity, human interaction, about social media, so social networks and connections in a way to achieve what we were saying before about what an intelligent building can do. So again, this is happening with a technology that's not being used in other parts of the world. It's actually being used just if you think about the United States, in the new Amazon shop. It uses the same facial recognition, so it knows who's there, what you're buying, and so on. But certainly, facial recognition has a lot of potential issues in terms of privacy, but can revolutionize many aspects of our lives. And again, office buildings in China or the Amazon shop are just the tip of the iceberg of what we can do. Yes. Many hands. Yes, maybe.
Last year, we had the chance to listen to Carlo Limpson, I think it's his name. It's a professor at MIT, and it was all about AI. And so exposing AI to an amount of different artists, the robot managed to come out with a lovely painting, or same thing applied to the robot coming out with different designs for chairs or tables and furniture pieces. Would you envision AI, giving the AI certain criteria, exposing the AI to an amount of buildings from Le Corbusier, whatever, and giving the AI certain criteria, would you see AI projecting and designing the optimal building, giving a certain space and knowing where the sunlight comes, the sun rises and goes down?
Thanks. Thanks for asking this. So basically, you want me to comment if AI will also put architects out of the job market, and I'll tell you what I think. One of the categories that will go out of the job market soon is traditional engineering, Because traditional engineering can really be automated with AI, especially if you got a digital twin or you got like a BIM system. And then in that BIM system already today, you can run all of the structural calculation, the M&E planning. You can do it. That's quite repetitive, and AI can do it very well. So imagine 5 or 10 years from now, the traditional work of a structural engineer will not exist anymore because all of that can be automated. Now, on the actual design side, it's interesting because if you just wanted to learn from the past, AI, what it does, it has what is called a training set. So you feed it a lot of information, and then it learns from that and keeps on doing something similar. So if you just wanted to produce more Le Corbusier building, probably you could take think about the first phase of Le Corbusier, where buildings that were quite similar, it was called the purist phase, and then you could feed all of that into an AI system, and then it could produce additional variation of similar things. But I think in architecture there's more than that, and it's really about designing something that has not been done already. And I think for that, AI doesn't work. AI learns from the past and try to extrapolate from the future from the past. So it's very good if you are, even for a self-driving car, you teach the system, how you drive well, and it will keep on doing it. But I think in architecture, in art, you got a lot of things that go beyond redoing the past. And so I think there's still a lot more potential for human input.
I was curious, you spoke about changes in cities and mobility and office, and I was wondering about the home. Should we expect the same type of changes, more disruptive, less disruptive, different?
Yeah, totally. Actually, we didn't have enough time to go through it, so I removed that part. I think what we are seeing today, the interesting thing about co-working, if you look at it, is that like a few decades ago, for an office space, for every person, you had anything between 10 to 20 square meters for that person. Now today with co-working, you go down to something that can be 5 or 6 square meters. And what's happening is that basically you're using space better, because a lot of the time, in an office, you got an empty space that is locked. Think about my office now at MIT. It's a traditional office. I'm here. Nobody's accessing it. It's not just real estate that's unused. If you go to a co-working paradigm, that space, when I'm not there, can be used by others. So when you sum up all the occupancy patterns, you have a much better utilization of space. You can fit more people on the same square meters. So if you do it well, what you have is actually you have more people per square meter, well, less square meter per person, same thing. And then at the same time, you create much more human interaction, which is a very important thing, much more community. So it's kind of a win-win. It's a win if you're a developer, because you get the same service with less investment. It's a win if you're working there because you create a richer human interaction. Now, the same thing seems to be happening in housing to a certain extent. And there's two forces that go in the same direction. Now, the first one is that in many big cities, the housing market is so expensive. It's pricing out so many young people out of, say, the London, the New York, so the Shanghai of the world. And so if you go to a co-living paradigm, you can actually downsize a little bit. So it's more affordable. And then you socialize some services, which again creates more like an interesting community. Again, if you think about why should every small apartment have a big dining room that you use once a week or twice a week, you could socialize that into a much more amazing kitchen that you share with other people. So I think the co-living is something that's changing as well. I think it's taking different flavors, different communities. If you design an apartment more for millennials or a senior housing, they can be different. Some of the most interesting things, we've been working a bit in China on combining the two, actually combining, it becomes interesting combining senior housing with housing for, more like student hotel type of housing. So I think something that is happening is a bit behind. I think in the commercial real estate, it happened faster with offices, but I think we're seeing a lot of the experimentation. If we play it right, we might get something more affordable, and again, it creates more community inside the building.
Thank you. I'm just going to invite Dan to ask the last question, and then for those of us who still have questions, I'm sure Professor is going to be willing to stay behind.
Sure, and we continue the conversation tonight at the gala as well.
Oh, thank you. So regarding mobility, when do you think we might get to level 5 autonomous driving? And following up with that, there's got to be some sort of a transition from, say, 99.9% human driving to what was demonstrated in the video of 100% autonomous driving. And how does the transition work? And then the third part is if you get to a, say, suburban or rural environment where you have a four-way intersection that's unlighted, and now you need a little bit of intuitive behavior, whereas in an aggressive market, maybe like Naples or Brooklyn, where people are, pushing through, versus say the South of the United States, where politeness prevails and everybody is waiting for somebody else to go first?
Sure. I think the great questions. So let me start from the first one about the level 5 autonomy. Level 5 means you can be in the car, you can sleep, and the car will take care of everything. While level 3 is more like the autopilot you have today on a Tesla. So the Tesla can run under some conditions, but you need to be ready to take over. And then you go level 4 in the middle. Now, level 5, however, depends on two key parameters. Autonomy depends on two key parameters: the complexity of the environment and the speed. If the environment is very complex and you move very fast, it becomes more difficult, both for a computer or for a person, for a human. So it's not an absolute definition, but it depends on those two parameters. So for instance, already today, if the environment is not too complex and you're not going too fast, you can have level 5. And that's why, think about, what Google sister company Waymo is doing, for instance, in Phoenix, is going in this direction. Is basically, you consider it getting very close to level 5. There's a person who's on the back seat, but basically the car is managing most situations. Now, under some condition, I think we might never be able to solve it, like for humans. Think about, one of the problems with self-driving cars is when there's a lot of snow, and then the car doesn't see anymore, the different signs and visual clues in order to drive. And then, but the same happens with us. If we're in the middle of a snowstorm, also a human driver might have difficulties. Sometimes we need to stop and just wait for the snowstorm to finish and so on. So I think under some conditions are challenging for us as well, in the same way as they're challenging for the machine. Having said that, I think most people in research believe that it's something that's in between 5 to 10 years as a time frame. So quite short in order to get there. And again, it will be something where we start from what we have today and we make it more and more autonomous, and we'll get there step by step. Which is your second point. It was about a transition. I think at the beginning, the transition is not going to be a big issue. It's like the autonomous car is just doing autonomously something that we are doing with humans. So it's like take the human brain and replace it with the AI system. So the two can coexist very easily. I think the big question I think you're referring to is, at one point, some things you can only do if everything is autonomous. So will we get to the condition where people will not be able to drive a car under some condition, and only autonomous cars will be allowed? And I think that will be a political decision. So it's not something we can predict. It will depend on what we decide. But if you look at what happened with horses, for instance, there's places where horses are banned. Like 100 years ago, people would move with horses, and little by little, they've been banned from some parts. Today, if you wanted to go on a highway with a horse, you cannot. So I think we'll need to see. It's a political decision. And we need to see how it develops. So I don't see a problem with the transition at the beginning, but more in the later phase.